I'm going to take you through the BioSim data resources from PSDI, and we can access these from the PSDI website. If we go to what we provide and data sources, there is a list of data sources available currently from PSDI, and we're looking at BioSimDB. This is the database where users can deposit their biomolecular simulations. But within our resource theme, we also have other tools available for collecting the full provenance of simulations so that all the steps that are performed when you're setting up your simulations can be saved in one convenient place and then also deposited along with your simulation data. So we have plugins available for Amber and Gromax MD engines where you can save provenance. And we also have a database demo where you can view your archive files that contain your provenance. We also have tutorials available for trying out our provenance tools with some simulations as examples. First, I'm going to go through depositing simulations on BioSimDB. So BioSimDB lives in the data collections part of PSDI, and here we can see a few entries that have been uploaded on BioSimDB. Here's an example of a DNA mini circle, which was originally donated to SlimMD on CCPBioSim. And here we have the topology and trajectory file containing the positions of the atoms in the simulations, along with a snapshot of what's in the simulation. There's also the link to the publication from which the simulation was performed, and then also some domain-specific metadata associated with the simulation. So if you are part of a UK institution, then you can upload your simulation data to BioSimDB. All you need to do is log in. So I'll show you here, log in. And you just need to provide your UK institution sign-in to log into PSDI. So select your institution and then you'll be redirected to your institution login page. Once you've logged in, you can then join the BioSimDB community to upload your simulation data. So you can go to communities and you'll see BioSimDB and Data to Knowledge are the current communities available in data collections. And you can join BioSimDB by going to the About tab and then go to Request to Join. Here you just need to provide your name, your email address, and a short justification for why you'd like to join BioSimDB. If you have any problems with logging in, joining a community, or uploading your data, please feel free to contact us on support@psdi.ac.uk. We will have a look at any of your queries and try to resolve them. So once you've submitted your request for membership for BioSimDB, you can then start depositing your simulations to the database. So if you go to communities, you should then see in your communities BioSimDB. If you click on that, you can then upload a new deposition. Any of your depositions that you are currently in the process of making or have made can be seen from your dashboard where you would have your uploads for each of your simulations. So here's an example of a current draft where we've uploaded files for the topology and trajectory of the simulation. As long as these can be read with the MD Analysis Python package, we will accept the deposition. You can also provide an image, such as a snapshot of your simulation or an abstract figure. The data resource type will usually be a dataset, and then you just need to provide a title for your simulation, and then also a description of your simulation. This particular simulation was first donated to the SlimMD provided by CCPBioSim, which we are transferring onto BioSimDB. But please do provide a description, like an abstract, of what the simulation is, why it was performed, and anything scientifically significant about the simulation. Now, if you've ever uploaded data to Zenodo, this form should look familiar. So we're using the same backend as Zenodo, which is in Vimeo. So hopefully this form will be easy to use, as you may have used it previously. The one difference with this form is that we do have a section specifically for BioSim domain-specific metadata. And here you can provide some more information about how you perform the simulation, what you performed it on, for example, and what frame steps you've used, for example, any simulation conditions, any force fields that were used, any particular experimental structures that were used to set up your simulation. Now, at the moment, this metadata you can provide manually, but we will be developing tools that will be available in the near future to extract most of this metadata. The extraction of the metadata will be carried out from your uploaded simulation file, so your topology and trajectory. But also, if you use our provenance tools, where all your input parameters and all the steps that you've performed to perform your simulation are saved, we can then use those provenance files to extract all applicable metadata from them automatically so that you don't have to. Cool, so once you have finished with your upload form, you can then submit it for review. So here's an example of a draft that has been submitted for review. And you would see it's in review and you can view the request. And here you will see a conversation with the reviewer and yourself, where the reviewer can provide you with information of possible things that you can change in your upload record to make it more easy for other users to find your data or any information that might be missing that might be relevant for your particular simulation. Once the reviewer is happy with your upload, they will accept and publish your record. Once your record has been accepted and published, you would be able to see it on BioSimDB, and also in your dashboard you'll see a green tick to say that it has been published. So here would be where you'd find the records that are currently available on BioSimDB. I'm going to show you an example where a provenance file has been uploaded with the simulation data. So we have two simulations, a topology, trajectory, and a topology and a trajectory, and then also a .AiiDA file, which contains the full provenance of setting up the simulation. This .pdf shows an example of what this provenance file contains, and it shows all the inputs and outputs for all the steps that were performed. Now, each of these commands will be packaged in the AiiDA file, and all the input files and the output files for each of these steps are also available and can readily be parsed and extracted for metadata that is specific to biomolecular simulation. So each upload or each deposition has a total file size limit of 100 gigabytes. If you do want to provide data that is more than 100 gigabytes, please feel free to email us at support@psdi.ac.uk or submit a record and have a conversation with your reviewer to see if you can upload larger files. If your simulations are important in the scientific community, we will try our best to accommodate your larger simulations where applicable. So this is where we currently are with BioSim data resources. We have a data service available where users can deposit their simulations and share them with the wider scientific community. And we also have provided provenance tools that allow users to capture as much of the information for how those simulations were created and can be shared then on BioSimDB as well. We also have training resources where we have examples of using AiiDA GROMACS to save the provenance of simulation data. So this is how we see BioSim data resources working, where users create simulations and the workflows associated with them as they perform them, and then share them on BioSimDB, or if they want to, any other databases that they feel like they would like to share them. And then we would like to allow users to find these provenance files and simulation files and either replay simulations or see how they were performed and use them for their own systems, modify workflows, and then upload their own workflows onto BioSimDB. We'd like to connect with other databases such as MDPosit, where they provide tools to visualize and analyze simulations. So we would like to work with as many of the BioSim resources that are available outside of PSDI and make sure that we can be interoperable with them.